Okay, today we're looking at Chapter 10, Lesson 2, Arithmetic Sequences and Series. We're going to start off with a key concept for finding the nth term of an arithmetic sequence. Basically, it says the nth term of a to the n, a sub n, of an arithmetic sequence in which the first term is a1 and the common difference is d, is given by the formula where n is any natural number, a sub n equals a1 plus n minus 1 times d. So we're going to apply that formula in the first example. First example, we need to find the 20th term of the arithmetic sequence 3, 10, 17, 24, and so on. So the first thing that we're going to need to do with an arithmetic sequence is to find the common difference. You can find that by subtracting any term from the term that came before it. So you have 24 minus 17, or 17 minus 10, or 10 minus 3. Either time you get 7. So our common difference is 7. Step 2, we're going to find the 20th term by plugging the numbers that we know into the formula. n is 20 now, so a sub 20 is the first term, 3, plus n minus 1, 20 minus 1, times the common difference, 7. This comes out to be 136. So the 20th term in the arithmetic sequence is 136. All right, here's one to check your progress. Go ahead and pause the video. You're looking for the 17th term for the sequence 6, 14, 22, 30. We're going to head on to the next slide to see the answer. But make sure you pause the video and try to work this out yourself first. And the answer for this problem is A134. For example 2, we're going to write an equation for the nth term of the sequence -8, -6, -4, and so on. So this time, what we need to do first is figure out the common difference, just like the last time. You get a common difference is 2. You're going to plug that into the formula along with the first term, -8. And once you simplify, you get a formula, 2n minus 10, for the equation for the nth term. For part B, we're going to write an equation for the nth term given only the 6th term and a common difference. So when you're given this, the first thing you want to do is work backwards to find what the first term would have been. So if you know the 6th term is 11, then n would be 6, and a sub n would be 11. D is -11. You can plug all that in. This will simplify down to help you solve A1. You could have also done a long way, and if you knew that the pattern was subtracting 11 every time, then if A6 is 11, A5 would have been 22, A4 would have been 33, etc., working all the way back to A1. But the method that is shown here is going to be faster than just working backwards using the common difference. Especially if they give you, rather than like A6, if they give you like A34, you don't want to work backwards 34 times to get back to the first term. So we know the first term in the pattern was, the sequence was 66. Then what we're going to do is write the equation, plugging in the 66 for A1 and -11 for D. Simplifying down, you get the pattern. The equation is -11n plus 77. Okay, here's 2 parts to check your progress on. Go ahead and pause the video, read through the question. I'm going to go ahead to the answer on the next screen. And the answer for this one is B, 9n minus 21. Looking at part B, go ahead and pause the video and read through the question, work it out, and we'll find the answer on the next screen. And this time the answer is A, 5n plus 25. Okay, checking out example 3. This time we are looking at how to find an arithmetic mean. Remember, the word mean means an average. We need to find the arithmetic means in the sequence 21, blank, 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 45, and so on. So this time, when you have this kind of problem, what you want to do first is to figure out n. And so you can see that there's 3 terms, obviously, that we don't know in the middle of the problem, plus the 2 terms that we do know gives us 5 terms that we see here. So the first thing you're finding out is n. Then step 2, you're going to find d. And you can find d using this method, like the formula that we already know. Plugging in n is 5, and the first term was 21, and the 5th term was 45 up here. Then the only thing that you don't know is d. You can work down and solve for d and get d as 6. Once you know that d is 6, you basically just can work through to fill in the numbers. So if you know the first number is 21, and you're going to add 6, 21 plus 6 gives you 27, plus 6 gives you 33, plus 6 gives you 39. That's the quickest way then to just fill in the numbers that were missing from the sequence. So 27, 33, and 39 are the arithmetic means. Here's one to try on your own. Go ahead and pause the video. We're going to show the answer on the next screen now. We see an answer of A, 16, 19, 22. Okay, the next concept is the partial sum of an arithmetic series. There's 2 formulas to look at this, 2 ways of expressing the formula based on what you're given at the beginning of the problem. If you're given a1 and an, you're going to use the formula n times a1 plus an over 2 to find the sum of the first n terms. If you're given a1 and the common difference, you're going to use the formula for the sum is n over 2 times 2a1 plus n minus 1 times d. So now we're going to apply those formulas in example 4 using the sum formulas. We're going to find the sum of 8 plus 12 plus 16 plus etc. plus 80. So doing this by hand would be a whole lot of work, because not only would you have a lot to add, you also have to find all the missing numbers that are in between here that they don't show you. So because of that, that's why these formulas were identified. The first thing that you're going to want to do is write down the first term and the last term and figure out the common difference. So obviously the first term and the last term are easy. The common difference, it's also easy, but it's not just written right in front of you. You have to do a little bit of math. How far is it from 8 to 12, from 12 to 16, etc. You can tell that that's 4. Then you're going to plug those values into the formula, and that's going to help you solve for n. So once you do that, you can see that we get n is 19. Once you know that n is 19, you can plug in to whichever one of the formulas that you want in this case. They chose to use the second formula, so they used n over 2 times 2a1 plus n minus 1 times d. We know n is 19. We know the first term was 8. We know the 19th term, n. We know n was 19 again. We know that common difference was 4. You plug all that in and simplify, you're going to get 836. And these 3 steps were obviously a lot easier than by hand adding 8 plus 12 plus 16 plus 20 plus 24 plus 28 plus 32, etc., 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 all the way up to 80. Okay, and here's one to try on your own. Go ahead and pause the video. Follow the same method that we did earlier. We're going to go ahead and look at the answer on the next screen. And the answer is choice D, 365. Okay, example 5. This time we are going to be finding the first 3 terms in a sequence. Find the first 3 terms of an arithmetic series in which the first term, A1, is 14, the nth term is 29, and the sum of n terms is 129. So this time, because we know the first term and the nth term, we're going to use the first version of the formula for finding the sums, which was the sum is n over 2 times a1 plus an. We know a1 and an are 14 and 29, and we know the sum is 129, but we don't know n. So we're going to have to do some algebra to work out getting n by itself. Once you do that and solve the equation, you get that n is 6. So if you're finding the first 3 terms, we know that this is the 6th term. Then we're going to go back and use a method from a previous example to figure out what the terms in the middle were. So we're going to plug in n is 6 now. We know the first term was 14, the nth term was 29. Plugging all this in, solving for d, we get the common difference is 3. And then because we know the first term was 14, you're just going to add 3 to get 17 for the second term and 20 for the third term. So the first 3 terms were 14, 17, and 20. Now we got one to check your progress. Try this out on your own. Go ahead and pause the video, read through the problem, work out your answer, and we'll see the answer on the next screen. And our answer for the first 3 terms is B, 11, 16, and 21. Okay, another concept, sigma notation. So this is a sigma, it's a capital sigma, it's a Greek letter, it means sum. This notation is just a nice, quick, easy way to express finding the sum based off a formula. The number below the sigma sign is the first value in your series. The number on top is the last value, and then f of k is the formula for finding the different terms of the series. So example 6, so we need to evaluate the sum from k equals 3 to 10 of 2k plus 1. So our process for this, the first thing that we want to do is obviously read it. We need to find the sum of the series. So to do that, we're going to need to find the first term and the nth term and n. So the way we do that is we're going to first take the first number in the series, which was 3. That was the first term. You're going to plug that in to the formula, which was 2k plus 1. So the first value of k. So 2 times 3 plus 1 gives you 7. You're going to take the last value of this term, the series, which was 10, because that was the number on top of sigma. Plug that in and you get 21. And then think about the fact that if you're starting at the number 3 and you're going to the number 10, from 3 to 10, there's 8 terms. So 3, 4, 5, 6, that's 4. 7, 8, 9, 10, that's 4. Together that makes 8 terms. So that means the 8th term was 21. The first term was 7, the 8th term was 21. You plug that in, n is 8, first term was 7, nth term was 21. Simplify this down, you're going to get 112 for the sum. That's one way of doing this. Another way of doing this would be to just directly plug in all the numbers. You can see this is more work, getting all the values and adding them up, and you still get 112. So our answer for this one, it was D. D was 112. Here's one to check your work on. Go ahead and pause the video, read through the problem, work it out. You can use method 1 or method 2. It's your choice. Method 1 is faster. We're going to see the answer on the next screen. And our answer for this one is choice C, 108. And that brings us to the end of this video.